we want to determine the second and third derivative of the given function. In order to determine the second derivative and third derivative, we do have to start by finding the first derivative. And looking at the given function, we'll first have to rewrite the second term as x raised to the negative third power. So to apply the power rule, we'll write this as 4x to the fifth should be minus x to the power of negative 3. And now it's in the form where we can apply the power rule. But notice now that we've learned the chain rule, the extended power rule does include the chain rule. But looking at these two terms, notice that u would be equal to x, therefore u prime would be equal to 1. And when u prime is equal to 1, we don't need to apply the chain rule, we can just use the basic power rule. So our first derivative is going to be equal to, here we'll multiply by 5 and subtract 1 from the exponent. That'll give us 20 x to the fourth. And here we're going to multiply by negative 3, so that's going to become plus 3 x to the negative 3 minus 1, that's negative fourth power. And since we're not asked to determine the first derivative, we'll go ahead and leave it in this form to determine the second derivative. So the second derivative is equal to the derivative of the first derivative. So we'll have 80x to the third, and here we'll have minus 12 times x to the negative fifth. And let's go ahead and rewrite this with a positive exponent. So we'll have 80x to the third minus 12 all over x to the fifth. Now these terms are simplified, so we could leave it in this form, but sometimes you'll see some textbooks combine these two terms by obtaining a common denominator, in this case of x to the fifth. So if we do that, we'd multiply both the denominator and the numerator by x to the fifth. So now we'd have a common denominator of x to the fifth, and our numerator would be 80x to the eighth minus 12. And now we do have a common factor in the numerator. We could rewrite this by factoring out the 4. We'd be left with 20x to the eighth minus 3 all over x to the fifth. Now these last two steps might not be necessary, but they would be equivalent ways to express the function. Now to determine the third derivative, we need to find the derivative of the second derivative. And to do that, we'll actually find the derivative of the second derivative in this form here. So the third derivative would be equal to multiplying by 3 and then subtracting 1 from the exponent. We'd have 240x squared. Here we're going to multiply by negative 5. It's going to be plus 60, and then subtract 1 from the exponent, so we'll have x to the negative sixth. Again, let's go ahead and rewrite this with a positive exponent. So we'd have 240x squared plus 60 all over x to the sixth. And again, this might be the form you're looking for the third derivative. But again, if we wanted to add these two terms, the common denominator would be x to the sixth. So we'd have 240x to the eighth plus 60 all over x to the sixth. And again, the numerator does factor. There's a common factor of 60, so we could factor out 60. So we'd have 4x to the eighth plus 1 all over x to the sixth. And again, these last two steps might not be necessary, but just in case you're trying to match a specific form of a function, here's how you can do it. I hope you found this helpful.